All right, Colton and Aubrey, we are now on section 2.4, and guess what? Section 2.4 is halfway through the chapter, which means not tomorrow, because everybody's gone tomorrow for Husker Harvest Days. Not tomorrow, but Thursday, not for this, Thursday, we will be taking mid-chapter quiz, which you can use your notes on, but Thursday's mid-chapter quiz. Are we prepared for that? That's halfway through the chapter, mid-chapter quiz. Here is the homework assignment for 2.4. This is kind of an easy homework assignment. Half of this is super easy. Half of it, there's a little bit of work you have to do, okay? And we'll get to that. Write this homework assignment down. Here it is, okay? All right, let's go to the top. We're going to roll right on through the first couple of examples and go really fast, okay? First couple of examples. These are transformations in the plane. You got to listen. Transformations in the plane. All right. The only transformations that we are doing is something called today, we're only doing congruence transformations. Yes. So we are doing transformations that are congruent. So what I'm doing is I'm taking an object, I'm doing one of these transformations, and it will remain the same shape and same size. That's called a congruence transformation. The three types, the three types that we're doing are a reflection, rotation, and a translation. People get the words transformation and translation confused. What is a translation?
When you move it.
This is a slide, or when you just move it, right? Okay, a transformation is all three of those together, right? Transformation is the umbrella term. Reflections, rotations, translations, those are the things that you could do, okay? Now, Zach over here said we left out one, which is called a dilation. D-I-L-A-T-I-O-N. Do you know what a dilation is? Larger or smaller? Because when we do that, when we do a dilation, is it congruent? Is it the same shape, same size? No. That is something called a similarity transformation. Okay? Similarity transformation means similar. Same shape but different size. So that's what a dilation is. So we will do dilations eventually, like in chapter 3. But for now, it's just those three. Okay? All right, here we go. We're going to go through these really quick. They give you what a reflection is. You're reflecting it across the line. Notice that they do this. They have A here, B here, C here. Those are vertices. This guy is A prime, B prime, and C prime. That just shows you which one is the second one, right? A prime, B prime, C prime. That's those little tick marks above. A prime, B prime, C prime. That's that, okay? Translation. We started with that object up here. We went down this way, and this is my second object. Here I have rotated it. Here's my start. Here's my end. Got it? Beautiful. Okay. Example 1. Identify the type of rigid motion transformation shown in the figure as a reflection, translation, rotation. Which one would you go with? Reflection. I'm just going to circle it and be done. Do we see that that's a reflection in the water? Okay, this checkers game, this is a translation, right? Because we're sliding the little checker piece. Okay? All right, identify it as a reflection, translation, rotation. What is A?
Question about that, on the pictures. Like, say it's a moving car. Would that be a translation or a rotation because the wheels?
It depends on what you're talking about. If you're talking about the car itself, that would be a translation. If you're talking about the wheel, it would be a rotation. Hypothetically, I would say translation. Because it's a picture of the whole car. If they just wanted the tire, they would take a picture of the tire, and that would be a rotation. Got it? Okay, what is A, though? Hold on.
Translation.
A is a translation. Okay, B. Oh, that is A. Ha. B. What is this one? This is A. Is that supposed to be a moon? It looks like a three-dimensional soccer ball or something, right? That is like this guy being flipped over here. That is a reflection. Okay? Judging by the colors. Do you see the two different colors? Okay, so we're looking at the moon shape. All right, that's a reflection. Go to the next page. This is a rotation. Got it? A rotation. All right, moving on down to the next thing. Now, we have the hard part. Are you ready for the hard part? Everybody listen. Everybody listen. Ready? Off here to the side. Put some things over here in this margin. I'm going to have you write stuff down. This is the hard part, okay? Three things going on. We have a reflection. Okay, reflection. And we're going to write some rules down. Let's see what we got going on. Hold on. Okay, reflection. There's 3 different types of reflections that we're going to do. I don't know if they do all these, but I do 3 different types of reflections. So we can reflect something across the I'm going to say over the x-axis. Okay? We could reflect something over the y-axis. And we could reflect something over the line y equals x. So you're writing this down. These are the rules. You need to write this down all in one spot. Reflections. Okay? All right, don't write this part down. Here's what we're going to do. Let's say we have a dot right here, which is the point 2, 3. And I want to reflect that across the x-axis. Where does he go?
2, -3.
He goes down here. Across the x-axis, he is now 2, -3. So if I'm reflecting across the x-axis, my xy coordinate, what happens to him? The y becomes negative, yeah? Across the x-axis, the y becomes negative, right? 2, 3 became 2, -3. Okay? Let's go back to that same point right here, and let's say I want to go over the y-axis. He's going to become -2, 3. So what happened to that xy coordinate? He becomes -xy, right? Okay? Over the x and y axis, the opposite one becomes negative. Do we know these rules? We did these in trig class, did we not? Like a long time ago. All right. Now, over the line y equals x. Okay? The line y equals x is a dotted line that goes here. Right there. 2, 3. Across the line y equals x, that would move him like there. What happens to him? Nope. Because he's here. So 2, 3, which was above here, would now go across over here. He would become 3, 2. So what happened to him? What's his rule? XY becomes YX. Are you writing these rules down so they're all in one spot? Yes. Yep. Okay. That is for reflections. Got it? Okay. All right. The next one is a translation. Okay. Here's how a translation works. They will a lot of times do translations in these little triangular brackets right here, like this. Okay? So they'll say a translation in triangular brackets. So let's say, I'm going to do an example with this, okay? Let's say I'm going to the right 4 and down 6. I want to take my shape that I have and I want to move them to the right 4 and down 6, okay? Left and right has to do with the x coordinates. I'm going to put that here. Down 6 is going to be, or up and down has to do with the y coordinates. So what I'm going to do is if I'm going to the right 4 and down 6, let's say I'm starting with the point 1, 1. That's my original point, and I want to go right 4 and down 6, right? When I'm going to the right 4, that means I'm adding 4 to the x coordinate, right? I'm going to the right, that's positive x direction. Down 6 means I am subtracting 6 from the y coordinate. So if I'm starting at 1, 1, my new point will be at 5, -5, yeah? 1, 1 will become 5, -5. Right 4, down 6, you're just adding 4, subtracting 6. Do we see how this works? Translation is the easiest one. You ready for the hardest one? Rotation. Okay? There are 3 different types of rotations, and these are the ones that you really have to study. Okay? How you rotate. Okay, we can rotate something 90 degrees. We could rotate something 180 degrees, and we could rotate something 270 degrees. Okay? Now, real quick. If I rotate something up here in the first quadrant and I rotate him 90 degrees, what quadrant will he be in?
Clockwise or counterclockwise?
If it doesn't say, which way do I go?
Clockwise.
You go counterclockwise, right?
You go 1,
When
2,
you're
3,
dealing with-
4.
okay.
Quadrant. 1, 2, 3, 4.
Jack knows the answer to this, or you go like, why are they numbered 1, 2, 3, 4 this way? It's when angles that are in standard position, and you'll learn this, angles in standard position rotate this way. So if they don't tell you and they just say rotate at 90 degrees, you're going to assume that it's going to be counterclockwise unless they say otherwise. Now, let's say they say 90 degrees clockwise, right? 90 degrees clockwise is the same thing as 270 counterclockwise. I'm going to go CCW for counterclockwise. Do we see how that works? 90 degrees clockwise is going to put us in the fourth quadrant versus 270 also puts us in the fourth quadrant. Does that make sense? Okay. Here are the rules for coordinates. Are you ready for these? Okay. X, Y. If I'm starting with X, comma, Y, here are the rules that happen to 90 degrees, 180 degrees, 270 degrees. Hold on. I'm going to do 180 first. Ready? 180. Here we go. Let's say I'm starting with 2, comma, 3. Don't write this down. Okay? If I make him 180, he will now be over here in this quadrant. He'll be right here. He will be at -2, -3. So what happens to him? They stay in the same spot, but they both become negative. Now, get this. This is really fancy. If you're rotating him 180 degrees, that is the same thing as reflecting him across the y-axis and then reflecting him across the x-axis, right? Reflecting him across the y-axis makes the x negative. Reflecting him across the x-axis makes the y negative. It's doing both of those at the same time. Does that make sense? Okay? So 180 is like 2 reflections, right? Across the x, across the y. Or across the y, across the x, whichever one you go first, right? Does that make sense? Okay, now here's the rule for 90 and 270. 90 and 270, the coordinates flip places. So they go y and then x and then y and then x, except one of them becomes negative. You ready? Here's how you remember. Y, x, y, x. 90 comes before 270. So this guy, I'm going to make him negative here in the first spot. 270 becomes negative in the second spot. Okay? So let's say I'm starting with 1, 4. Let's say I'm starting with 1, comma 4. If I want to rotate that 90 degrees, 1, comma 4 is going to change to -4, comma 1. Does that make sense? Let's say I'm rotating him 180. -1, -4. Let's say I'm rotating him 270. 4, -1. Do we see how this works? Okay. These are the rules. I just combined like 3 pages of notes into one. Here are all your rules. Okay?
Yay.
Yay? All right. Let's do some stuff. Reflecting in the x or y axis. In example 3, it says reflect this across the x axis. Okay? What's the rule for reflecting across the x axis? The y becomes negative. So, A prime, I'm just going to write these answers right here. A prime will be where? 3, -2. The y coordinate becomes negative. B prime will be at 2, 2. Yeah, if he's already negative, you make him positive. Got it? C prime will be at 4, comma 5. And we're done. Got it? We have the rules. That's what happens to him. And then we can plot him, but we're not going to do that. Okay? Example 4. All right, translation vectors. We have 4 points, Q, R, S, and T, and then they say this thing. I said translations use triangle brackets. 7, 1. What does that mean? What does 7, 1 mean? Just wait.
Right 7.
This is right 7 and up 1, because they're both positive, right? Right 7, up 1, okay? And I want to do that to each one of these. So if Q prime, if I'm going right 7, up 1, I just add those coordinates together, right? -8 and 7 makes -1. -2 and 1 makes -1. Where will R prime be? -2, -4. There he is, okay? S prime, +3, comma, -6. T prime, +3, -1. Yeah? Not too bad, right? Pretty easy. These are the rules, translations, okay? And we can plot them, but we're not going to do that, okay? Can I be lazy and not plot them? You have to do it on your homework assignment if it tells you to. But whatever. Okay, look at all the work that they show. Like, look at how crazy that is. Do it in your head. Come on. I mean, you know, whatever. Don't write all that crap out. Okay? All right, here we go. Last one. Rotations. Here are all the rules for rotations. We wrote them down on that first page. Got it? I'm saving like a bunch of pages. Here we go. 180 degrees about the origin. Let's write down the rule for 180. 180 takes x, y. And what does it do? They both stay in the same spot, but they become negative, right? Because 180 is like reflecting x and reflecting y at the same time. So what will f prime be? Negative 2, negative 1. G prime? Negative 7, negative 1. H prime? Negative 6, positive 3, right? And the last one, I guess, J? J prime? Negative 1, positive 3. Do we see how this works? Okay? That's shortcuts of how to rotate and do all the things, right? Okay, 1 through 8 should be really easy, or just reflecting, translating, rotating. Just tell me which one it is. Don't think too hard.
Well, is this
Okay.
guy trying to do a spin, or is he just skating along? I think he's just skating.
No.
Well, like, what about the dog?
The dog
He's translation. Transmuting.
Don't think too hard. Don't think too hard. Okay? All right, there you go. Good? All right, goodbye watching this video.